In 1901, in a museum in Athens, a lump of corroded bronze split open on a shelf. It had been pulled out of the sea the previous year, along with a great deal of far more impressive material, and nobody had paid it much attention. It was the size of a thick book, green, crusted, shot through with rotten wood, and inside it, clearly visible now that it had cracked, was a gear wheel, not a rough cog, a precisely cut gear with fine triangular teeth of the kind you would expect inside a clock. The object it came from was made somewhere around the 2nd or 1st century BC, and nothing remotely like it appears anywhere else in the archaeological record for another 1400 years. This is the story of what that thing was, how we worked it out, and the part people usually get wrong, which is the question of why it seems so impossible. Start with how it was found, because that is a story in itself. In 1900, a boat of Greek sponge divers was working its way home across the Aegean. They were caught by weather and sheltered off a small rocky island between Crete and the mainland. While they waited, they dived, and one of them came up badly shaken, describing a slope of the seabed covered in bodies, horses, people, limbs. He had found a wreck about 45 meters down, and what he had seen were bronze and marble statues scattered across the slope where a cargo ship had gone down roughly 2,000 years earlier. The divers reported it, and the Greek authorities mounted a recovery operation that ran for about 2 years. It is generally considered the first major underwater archaeological excavation ever attempted, and it was done with the equipment of the time, which meant canvas suits, copper helmets, and air pumped by hand from the surface. Nobody yet properly understood what happens to a body that comes up too quickly from that depth. One of the divers died. At least 2 others were left permanently disabled. That should sit in this story alongside everything else, because the objects now displayed in Athens were brought up by men who did not know what the depth was doing to them. Among the statues and the glassware and the coins was the lump. It went into storage with everything else, and it was only weeks later that an archaeologist looking through the recovered material noticed the gear. And then, for a long time, almost nothing happened, because the problem with the object was that it did not fit. Gearing of that precision belongs, as far as anyone knew, to medieval Europe. The obvious conclusion was that the lump must have fallen into the wreck later, or been mixed up in storage, or misdated somehow. That is a reasonable reaction. When one object contradicts everything else you have, the first suspicion should be the object. It took decades of work to establish that it genuinely belonged to that ship, and that the ship genuinely sank when it appeared to. The real progress came in 2 waves, and both of them were about seeing inside without taking it apart. In the mid-20th century, a historian of science began using X-rays and gamma radiography to look through the corrosion. He counted gears. He worked out some of the tooth counts, which is the crucial thing, because the number of teeth on a gear tells you the ratio it is calculating. And one of the gears had 223 teeth. Hold on to that number. Then, in the mid-2000s, a research team brought in equipment that had never been used on something like this. A microfocus computed tomography scanner built for inspecting industrial castings, which could produce a 3-dimensional map of the interior of a solid corroded object, and a surface imaging technique that lights an object from many angles in turn and combines the results to lift faint markings off a worn surface. What came out of that was not just the gearing, it was the text. because the thing had been covered in inscriptions, inside and out, and thousands of characters that had been unreadable for 2,000 years were recovered. The inscriptions are effectively an instruction manual and a description of what the dial showed. So here is what it actually did. On the front was a large dial with two concentric scales, one divided into the signs of the zodiac, one into the days of a calendar year. Pointer moved around this dial showing the position of the sun and the position of the moon against the stars. There was also a small ball, half silver and half dark, that rotated to show the phase of the moon on any given day. And there is a detail here that I find genuinely remarkable. The moon does not move across our sky at a constant speed. It speeds up and slows down because its orbit is not a circle. The mechanism modeled that. It did it with two gears mounted slightly off center from each other, one carrying a pin that sat in a slot on the other. As the pair rotated, the pin's changing distance from the center made the driven gear speed up and slow down through each revolution, a variable output from a constant input, built out of nothing but two bronze wheels and a slot. Now, turn it around. On the back were two large spiral dials, each with a pointer that followed the spiral round and round like a groove on a record. The upper one tracked a 19-year cycle, which is the period after which the lunar months and the solar year come back into alignment. That is the calculation you need if you want to run a lunar calendar that does not drift away from the seasons. The lower spiral is the one with the 223, because 223 lunar months is the eclipse cycle. After that interval, the sun, the moon, and the earth return to a very similar alignment, and eclipses repeat in a similar pattern. The dial had small glyphs marked around it indicating not just that an eclipse was due, but roughly when, and whether it was solar or lunar. There was also a small dial tracking a 4-year cycle of athletic games, including the Olympics, which tells you something about who this was for. It is not a purely astronomical instrument. It is also a civic calendar. All of that was driven by a single input. You turn a handle on the side, and every pointer on both faces moved to the correct position for that date. Around 30 gears survive. The original probably had more. Now, the part people usually get wrong, because this object gets described as impossible or out of place in time, and that framing leads somewhere unhelpful. It was not impossible. It was made by people using bronze, files, and a great deal of accumulated knowledge about how the sky behaves. The astronomy behind it was well established in the Greek world. The cycles it tracks have been known for centuries. What is unusual is not the knowledge. It is the decision to build the knowledge into a machine. And here is the crucial point. We have written references from the Roman period to other devices like this. A famous statesman describes an instrument that showed the movements of the sun, moon, and planets, attributed to Archimedes. So it was not unique. There was a tradition. We simply do not have any of the others. And there is a very ordinary reason why not. Bronze is valuable. Bronze is recyclable. For 2,000 years, every complicated bronze object that stopped working, or stopped being fashionable, or ended up in the wrong hands was worth more melted down than kept. The instruments were not lost to time. They were lost to reuse. Which means the reason we have this one is not that it was special. It is that it fell into the sea. It went down in a shipwreck, sank into sediment at a depth nobody could reach, and stayed there for 2 millennia precisely because no one could get at it to melt it down. The only surviving example of an entire technological tradition survives because it was lost. So think about what that implies about everything else. Not just this object. Every conclusion we draw about what people in the past could do is drawn from what happened to survive. And what survives is not a fair sample. It is heavily biased toward things made of materials nobody wanted to reuse. Stone survives. Fired clay survives. Things that fell in the sea survive. Complex metal machinery, which is exactly the category that tells you most about technical capability, is the category most likely to disappear entirely. The corroded lump in Athens is not an anomaly in the historical record. It is a hole in it, briefly lit up.